Okay, in this lesson, I'm going to teach you how to solve a trigonometric equation where we have reciprocal trig ratios involved here. So I'm going to do Roman numeral number 1 here, and we're going to try to solve for x. Now, as you can see here, secant is a reciprocal trig. So if you remember the relationship with secant here, secant x is equal to 1 over cos x. So it's the reciprocal of the cosine trig ratio. So please note the actual domain we're working with here. We are working with degrees. So we are going to use our calculator for this example, so we should be in degree mode. Okay, so the first thing we want to find out is where, let's replace this secant x with something a little bit more familiar, which is cosine x. So 4 times secant x is the same thing as 4 times 1 over cos x, and this is equal to -5. Now I'd actually rewrite that as 4 over cos x is equal to -5. Next thing I would do is actually isolate this trig ratio, cos x. Okay, so when you solve any trig equation, I always recommend to isolate the trig ratio first. In this case, it's the cosine. So to isolate, I'm going to go ahead and cross multiply this side. So I'm going to get 4 is equal to 5, or -5, times the cosine of x. Therefore, cosine of x is equal to the ratio 4 over -5. Now, the unit circle, we try to use that. It's always the first thing you should try. But as you can see here, there's no coordinate, there's no angle in the unit circle that's going to give you an x-coordinate of 4 over -5. It just doesn't exist on the unit circle. So as you can see here, our angle here is not going to be a special angle on the unit circle. But you could still solve for x. The process is as follows. The first thing you want to do is find out where could this angle lie. Okay, since we're looking at cosine is actually a negative value, applying a add sugar to coffee here, add sugar to coffee, cosine is going to be negative in 2 quadrants, in quadrant 2 and in quadrant 3. Okay, so it's not going to be in quadrant 1 or 4 because it has to be where it's negative, which is in quadrant 2 and 3. Now, these two possible solutions are going to have the same reference angle. So to do this question, we need to find out what is that reference angle. To find the reference angle, we're going to use the cosine inverse. So to find the reference angle, you have to take the cosine inverse of this ratio, but the positive case. The reason why we're not taking the cosine inverse of -4 over 5 is because a reference angle is always positive, always greater than 0. Okay, so we're going to take the cosine inverse of 4 over 5, and that's going to give us our reference angle. So let's go to our calculators here. Make sure you're in the right mode. We should be in degree mode. And we're going to take the cosine inverse of 4 over 5. So second inverse cos, and we're going to plug in 4 over 5, and we should get a measurement in degree. Let me just double check. Yes, so we're going to be in degrees here. So my reference angle is 36.9 degrees. Okay, so therefore, we have a 36.9 degrees. That is my reference angle. Okay, now it's not necessarily my answer, but it's going to help me find the answer. So this angle right here is 36.9 degrees. Okay, and also this angle here is also 36.9. Okay, so they're both positive because reference angles should be positive. Okay, now let's find our solutions. Now I think we want to find our solutions in a very specific domain. Our domain looks something like this. So it's kind of at first glance, it looks like a complicated domain to work with, but it's not too bad. So what I do with the domain here is I try to split it up into two cases here, one negative, one positive. So my first domain is -90 degrees. So everything greater than -90 degrees, but less than or equal to 0. So that's my first domain that I need to look at. And then, of course, everything greater than 0 degrees, but less than or equal to 180 degrees. So I just split it up into a negative and positive domain to visually represent where these solutions are going to lie. The first solution that we need to find, and I'm going to work with the positive case first, is between 0 and 180. 0 and 180, where is that? Well, here's 0, and 180 degrees is over here. So do we have a solution within that range? We actually do. We have one solution, which is from here to here. Now, how do we find that angle? We know the reference angle. So to find the angle from here to here, we take 180 degrees and we subtract 36.9 degrees. Okay, so if we put that in our calculator here, we're going to go 180. Okay, so minus your answer. So go second answer. You could use 36.9. It doesn't really matter. And our first solution is approximately 143 degrees. So here's my first solution. 143 degrees fits this domain right here. So that's where it comes from. Okay. Now we have a second domain to address. It's the negative domain. So from negative 90 to 0. So where will negative 90 lie? Remember, negative angles are in the clockwise direction. So here's 0 degrees again. Negative 90 is right down here. Okay, so we want to find out, are there any solutions in that range? And as you can see here, we have nothing in here. We have no solutions in quadrant 4. All my solutions are in 2 and 3. So there's no way there's a solution in that domain. So therefore, we conclude by saying that the one and only solution in my domain given is 143 degrees. And that's it for that question.